Session on Azure. So here we are going to discuss on the core fundamentals of what exactly data engineering is, how it is divided into its core parts, and then we'll be looking at how we can get started with the setup of data lake storage on AWS as a foundation service for storing the data in its raw format that is meant to be processed. So first thing first, if we talk about data engineering concept in general, so data engineering is what? It's basically going to allow us to process the raw data and collect data from multiple sources, let's say from e-commerce, from our ERP solution or CRM solutions, or website, or the streaming data all in a centralized place. And if you want, we can have it transformed and then we can connect it to any machine learning models or any BI tools so that we can generate and we can visualize the data set. For example, if you are working in a mid-sized company and that has been there for a few decades, so they have got data everywhere. So let's say there is a mix of old SQL Server databases, there are some Excel sheets on SharePoint, so there are some logs in Cloud Blob Store, and there are new product telemetry streaming in from the IoT devices. So business teams, they want some good insights. The analysts, they want dashboards, and the leadership wants AI powered. But none of them is possible if data is scattered, inconsistent, or just plain unusable. So if you talk about data engineering on Azure, so this won't be just about moving data. It would be about building and maintaining the entire pipeline that is going to get the raw silo data in a usable, trustworthy, and a scalable form. And doing it using the Azure ecosystem of tools and services would be beneficial. So at its core, data engineering on Azure simply means that we are building, we are integrating, optimizing, and maintaining the data solutions using Azure service to support the modern analytics, machine learning, and the business intelligence. So we can think of it like building a production line, but again, instead of manufacturing the widgets, we are producing a clean, reliable, and analytics-ready data. So the process typically involves four broad phases. First of all, we start with the first phase, which is the ingestion. The first phase is always the ingestion phase. So in the ingestion phase, what exactly we do is, as the name suggests, we try to collect data from multiple sources the way we want. So when we say multiple sources, so here we're talking about data in its raw format, in its complete raw format. So let's say here data can be the on-premise SQL Server, which can use the data factory or Synapse. So Azure Data Factory and Synapse, they are the core services offered by Azure as a part of their data engineering pipeline. We can have real-time data streams. So if we are having devices like we have IoT devices, we have the aviation devices, we have any service which is generating data in a real-time stream. So we can use, let's say, Azure Event Hub or the IoT Hub as a service. Then if you are having the APIs, the logs, the files, so in that case, we can go and think of them like the logic apps. We also have we can say data factory or the Azure function, so they can be easily ingested. Once data is ingested, then we move on to the next phase of transformation, because raw data usually is not useful as it is. We have to clean it, we have to standardize it, and then we have to transform it. So we use the Azure Data Flow or ADF pipeline for the batch ETL. And we can also use Databricks for more complex big data style transformations using Spark, or we can use notebooks and Spark SQL for scalable data setup. Then under the storage, we can organize data into the optimized format, because once data has been cleaned, where exactly we have to put it, there has to be a source for that, or there has to be, you can say, a data sink for that. So data lake storage Gen 2 is going to be a go-to storage for the lake house setup. and the Synapse analytics for warehousing can be there for fast SQL query. So Synapse is also a fully managed service offered by Azure that we can go ahead and make use of. And we can have Cosmos DB or the Azure SQL database for the operational or the transactional needs. Then for the serving, for serving the end users here, so we can make the data available to the consumers, analysts. They can query the data from Synapse or Power BI. Data scientists, they can read data from data lake storage into the machine learning models in Azure ML. And the applications, they can make use of REST APIs to consume the processed data from Cosmos DB. And this end-to-end architecture is going to scale automatically, which is going to allow us to integrate with the Azure security model that we have, the role-based access control, the Active Directory, and it is going to allow us to support the automation, the CI/CD pipelines, and even the cost optimization. So in simple terms, we can say data engineering is going to allow the team to move faster with less overhead, handle more data from sources more reliably, and it allows us to support modern workloads in terms of real-time dashboards, the machine learning AI, and it supports the modern workloads, including the security and compliances with the enterprise-grade security features available. So whether we are enabling the self-service analytics for hundreds of analysts or preparing some real-time inputs for fraud detection model, Azure will give you the toolbox to make that happen without reinventing the entire field. So that is what we can do here. And as a part of the data engineer, we will be responsible for setting up the entire end-to-end pipeline for different use cases. We will be responsible for the cross-functional collaboration. That means when you're working with data scientists, so they will be needing the access to the process data. Not that much we can say fine-tuned for the visualization, but when we are working with analysts, they would need to have the fine-tuned data along with some feature engineering done. And then when we talk about the data quality management, so data quality means we always have to process the data. We have to remove any kind of outliers that may be present in the data, and we have to remove them in the best way possible. So these things are going to be the case. So hope you all are clear to this part. Please give me that information. All right, so next we are going to look at how we can quickly go ahead and set up our data lake storage account. So let's move to the console. Now, next part is for the core services offered by data engine. Just a second. So next part is where we have these are the core services that we will be, as a part of the data engineer, will be working the most. First, the first service that we have is the Azure Data Factory. So this is going to be mostly used for the ETL and for the other orchestration components when we have a requirement of setting up the entire end-to-end ETL pipeline. So, example, suppose the leadership came to us and they want a data-driven and pipeline, and analysts, they are frustrated. They are waiting for days for reports. So we have got to scatter data across different sources, and we have a pressure to get clean and timely data. So first thing first, in terms of the data analysis purpose for your core components, we have the DF. Suppose we have the data scattered across on-premise SQL Server, we have something available in our SaaS-based system, like we have Salesforce, some logs are in S3. So how do we put all of that into Azure, clean it, and then push it into a center location every day? So that's where the data factory comes in. So we have a cloud-based ETL tool. So it doesn't store the data, it simply moves and transform it. And then we have the drag and drop interface where we can build the pipelines visually or with code. And then we can use we can go ahead and make use of 100 plus connectors based on SQL, REST API, SAP, file systems, the cloud storage, and more. And then we can run the pipelines on an hourly basis, daily, or even based on the events. And we can do the integration even with the Git as well. Second service that we have here is the Azure Synapse Analytics. So for Synapse, let's say we have sales, marketing, and operations data flowing in from ADF. So Synapse is going to be our go-to platform for big, fast, and interactive analytics. So there we have the massive parallel processing, which can handle large data sets efficiently. We have the TSQL support, which is going to be familiar to TSQL with powerful performance. And then we have the integration with the Power BI, where users can directly and visualize the data. And then we also get the hybrid workloads, where we can run both the SQL-based and the Spark-based analytics. And when you talk about the serverless or provision, then we can pay per query or provision compute. So using Synapse, we can have a central analytics layer. And then at last, we have the data lake storage. So when we are pulling in raw text stream logs, when you're working with the IoT sensor data, the full CSV done from third parties, it's going to be too big, too messy, or too raw to go straight into a warehouse. So that's exactly data lake storage Gen 2 is for, the hierarchical namespace, where we can act like a file system, like for folders, paths, public data. We can have it optimized for analytics. Let's say we can work with, it works natively with the ADF, Synapse, and Databricks. And we have a support for fine create access control, where we can integrate that with the add or the role-based access setup. So these are the core services offered. Thank you again, everyone, for